Okay, so we're talking about circles and their properties in here. And so we start off that we're given that we have congruent circles, which means that the radii are the same. And then we're also given that these chords, B, C, and D, F are the same. What can we conclude? Well, if those are the same, the triangles are the same from side, 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 and we can conclude that those central angles are the same, so angle O and angle P are congruent. And if you have congruent central angles within congruent circles, you know that your arcs are congruent as well. So we have arc BC and arc DF are the same. On our next one, we want to find x. Well, we're given a perpendicular from a center to a chord, which means it gets bisected, so that becomes 18 and 18. And so if we have the same chord between those two, then the distance is the same, and so x is just 16. So that's pretty straightforward. As we want to just keep in mind that we really have to have those congruent chords. The 18, the 36, the same as this piece here. So for our next one, it might look complicated, but it's really not too bad. If we look at this, it gets bisected because it's perpendicular, which means that my x, which is the whole chord down here, right, gets split in half. So I have x over 2. And now it's a Pythagorean theorem problem. So I set it up, a squared, b squared, c squared, and I plug through it. I subtract 16. I've got to be a little bit careful that my x over 2 squared is x squared over 4. I squared the 2 as well. Multiply by 4, I take a square root, and it's really, really close to 11. It's like 10.99, so we just use 11. So that's my x value. That's my chord length. And then the other one is to find the distance from here to this midpoint. So that's straight down. That might sound harder than it is, but really if you look at this, what we have is a radius, and so we just take away that piece that we were given, which is the 4, and we're left with 2.8, and that's our distance there.